Let's take a look at amino acids in more detail. Amino acids have this general structure where there is an amine group as well as a carboxylic acid group, both bonded to a carbon that's known as an alpha carbon. That alpha carbon is also bonded to a hydrogen as well as a side chain. At physiological pH, the carboxylic acid is deprotonated, which means it exists with a negative charge as the carboxylate ion. And the amine group is protonated, which means it has a positive charge. So we recognize this molecule with a positive and negative charge with an overall zero charge as a Zwitter ion. The side chain distinguishes amino acids from one another, and we'll look in more detail at the side chain and how it's used to classify amino acids in a few slides. You may have noticed that the alpha carbon has 4 different groups bonded to it, which means it is chiral. Glycine, however, has a side group of hydrogen. So glycine is the one amino acid that does not have a chiral center. Except for glycine, all amino acids have at least one chiral center. So we know that chiral carbons have enantiomers, which are non-superimposable mirror images of one another. And the amino acids that occur in proteins are always in the L configuration. And we can write sort of a Fisher projection of that, and the protonated amino group is always written on the left for the L configuration, and it's written on the right for the D configuration of an amino acid. 20 amino acids are found in most proteins, and your textbook lists their name as well as their structure, and it also designates 10 of those amino acids with asterisks. Those 10 amino acids are known as essential, meaning that humans must obtain these amino acids through their diet. You may have heard of a complete protein. That is a protein that contains the 10 essential amino acids. Most plant foods do not have complete proteins, but you can make a complete protein meal by combining plant foods so that all 10 amino acids that are essential are included.